Thank you. So before we get started, I just want to get a show of hands. How many people in here are using cloud-based servers like Amazon or Rackspace? Okay. How many people are using Boto and Fabric? Wow, this is like the Fabric side of the room over here. You guys all raised your hands. Okay, so some of this might be a bit rudimentary for those of you who've already used this stuff. I'm kind of targeting this at people who are new to Fabric and Boto, so if you already know this stuff, this might be a bit basic for you. But I'm going to give some examples of how we're using Fabric and Boto, which you might learn some new stuff from there. So first of all, who am I? So I'm a Python hacker. I came to Python through Plone. How many people here use Plone? It's a few. All right. Back in 2002, and before that I had been doing like PHP and ASP, those other technologies, and really loved Python and been using it ever since. I also started using Amazon Web Services shortly after they announced it, and over the years have seen that Amazon is really responding to the needs of developers. Like every time I think, wow, it'd be really cool if Amazon had this feature, then they announce some new feature. So I think that's one reason for their success, is that they're really thinking about what we as developers need. I also started a company called Jazzcarta back in 2004, mostly doing Plone at the time, and then in the last couple of years we've started doing a lot more Django development, although we still do a lot of Plone. And most recently, I started a company called DjangoZoom, which is going to be the case study for this talk. So I'm going to be showing examples of how we're using Boto and Fabric to deploy our infrastructure. So just talking about sort of what the game plan is for this talk, we're going to talk about why should you automate deployment? Why is that important? We'll give a brief intro to Amazon Web Services, for those of you that don't know what it is, and Boto. I'll give a short tutorial of how to use Boto. We'll talk about Fabric. And then I'll give some examples of how we're using it. And then we'll talk about some alternatives to these tools. And then hopefully we'll have lots of time at the end for questions. So, hosting and deployment challenges. There are a lot of things that if you're building a web application, you need to think about when it comes to procuring machines and making sure that those machines are maintained and making sure that it's easy for you to push your code up to those servers and do new releases. So some of the things that you might be thinking about is, if you need more server capacity, how long does it take you to provision those new resources? How long does it take to roll out a new release? Is it an hour? Is it a day? Is it a week? And if something goes wrong in your deployment, can you roll back to a previous version? And David Kramer gave a really great talk the other day about how they're doing this at Discuss and the importance of having a rollback in case something breaks. And if your servers have really serious problems, how much downtime can you afford? Like if you're running an e-commerce site and your servers are down, then like for every minute your servers are down, you're losing money. So this all depends kind of on what type of application you're building. And I heard this somewhere, I can't remember where I first heard this, but managing servers by executing commands via SSH is like writing code at the Python interpreter prompt. So, if you're still logging into your machine and doing stuff on the machine and you have no way of actually reproducing that, it's like a ticking time bomb, right? Because there's no history of what you did on that machine and how to reproduce it if the machine goes down or if there's some other catastrophic failure. So, in looking at these questions, it's useful to look at kind of what the differences are between traditional hosting and what Amazon provides. And I'm just going to talk about some of the differences between these two. So with traditional hosting, you have real hardware, typically, right? You have a machine, bare metal. For better or worse, that machine goes down. You've got to go to the data center and put a new hard drive in it or replace the fan or whatever. Whereas Amazon, they have lots of real hardware, but they provision you a virtual machine. And there's a lot of pros and cons to virtual machines, which we can get into. The other thing is with traditional hosting, just by default, you get persistent storage. It's kind of expected that you're going to get a hard drive and you can store your data on there, and that data is not going to go away. Whereas with Amazon, they have this thing called ephemeral storage, which means that the server could go down and your data could be gone, just like that. And we'll talk about what some of the solutions are for that. Also with traditional hosting, you just guarantee you're going to get a static IP, right? You boot up the machine and you have an IP address. Whereas with Amazon, by default, you get a dynamic IP that could change. If you reboot the machine, you might get a different IP. So that obviously has some ramifications if you're using that as your main web server. And then lastly, when you get a machine from a traditional host, they pretty much just give you the raw operating system, right? There's nothing else installed on that server when you get it. And Amazon has come up with this thing called Amazon Machine Images, which could just be a bare machine with just the operating system, but it could also be a full-blown stack of Python or Django or even higher-level applications like Plone. You could just boot up an AMI and it already has Plone set up and configured and installed. So let's talk a little bit more about the Amazon infrastructure. Amazon has been, as I mentioned before, releasing new features to their stack all the time, and the most popular one is probably the EC2, Elastic Computing Cloud. And this gives you virtual machines on demand. Basically one command and you've got a machine at your disposal. That problem I mentioned before about the storage just going away, Amazon came up with this thing called EBS, Elastic Block Storage. And this gives you persistent storage. It gives you a volume that you can attach or detach from any machine, and you can create snapshots of those EBS volumes and attach those volumes to other machines. So it gives you this very flexible way of moving data around to different machines. If a machine goes down, your data is still safe, and you can just reattach that volume to another machine. And I should mention that Amazon really encourages you to think of these machines as disposable, to think of a machine as something that could go away at any moment, and you should build your infrastructure to be resilient to that, which is a good idea anyways, but with Amazon you kind of have to. And then before I mentioned that there's these dynamic IPs that by default you get. Well, Amazon came up with this thing called Elastic IPs, which is a solution to the public IP, but it's even more interesting in that you can on the fly assign a new IP to any other machine in an instant. There's no DNS propagation wait time. They also have Elastic Load Balancing, which lets you load balance between different virtual machines. I already mentioned the Amazon Machine Image, which you can share with other people. S3, this is also a really popular service. CloudFront lets you take assets you have in S3 and provide them via caching. And then they introduced something called RDS, which is the Relational Database Service. And this gives you sort of like databases on demand. Right now it's just MySQL, and I think Oracle is supported as well. It'd be great if they would do Postgres, but I guess those are the first two that they thought they should provide. And they also do replication, so the databases are replicated across multiple data centers. So that's just a very brief overview of the Amazon infrastructure. It's kind of an alphabet soup. There's like all these different services that they offer. So what is Boto? Well, Boto is a dolphin that lives in the Amazon River. And it comes in two colors. It comes in pink and it comes in black. And it's said that the black Boto is the friendly one. It helps save people if you're drowning. You better hope it's the black Boto that comes to save you. But the pink one is dangerous. And these animals are interesting because they're nearly blind. But they have this sophisticated sonar system that helps them to navigate these muddy Amazonian rivers. So that's the origin of the word Boto, but it's also a Python interface to Amazon Web Services. And it was written by a guy named Mitch Garnett. Oops, did we just lose our connection? Oh, it's back. Okay, I must have stepped on something. Mitch is Python hacker who's been maintaining the Boto library since 2007, and he now works for a company called Eucalyptus. They provide like private clouds services. And Boto is great. It provides pretty much Python interface to everything that Amazon provides. Like whenever Amazon comes out with something new, Mitch and other people that work on Boto are quick to add that functionality. So I'm just going to dive into some code. This talk, I should mention, is pretty code example heavy. So I can show a lot of it, or we can skip over it and just get to questions really fast. So if you guys are getting bored with all the code, we can go to questions. But I thought I'd give an overview of sort of how to use Boto from a really basic level. So here we are at the Python prompt, and you just import the Boto library, and you set up a connection. You pass in your access key and your secret key, which Amazon provides to you. Or if you have the environment variable set, then it just reads that out of your environment, and you can just these 2 lines of code, and you have a connection to Amazon EC2. The next thing you need to do is you need to find an AMI, and remember that's the Amazon machine image, and we use the AMIs, the official AMIs from Canonical. So we're using the Ubuntu 10.10 image, which if you go to that URL, you'll get a list of all of them, and that's the one. For this example, we'll use. So the first part here is US East. That's the region that the AMI is located in. The second is what architecture. So they have 32-bit or 64-bit, and then this EBS thing means that the machine is actually booting off an EBS volume. So if you stop the machine, your data is persisted, unlike previous EC2 with the instant store, where if you shut down your machine, your data is gone. So we just by default use the EBS volumes because that's one less thing we have to worry about. Also, if the machine does happen to go down, you can't SSH into it, you can attach that EBS volume to another machine and recover your data. So that's also very useful. So we take that AMI ID and then we pass it in as a parameter to the run instance method. And then we also pass in the key name. So Amazon requires that you do key pair authentication. There's no passwords. There's no root password or anything like that. So you have to pass in your key pair if you want to be able to SSH into the machine. And then you basically just keep pulling until the state changes from pending to running. And that tells you that your machine is now online. Okay, so once the machine is running, then you can inspect it. You can find out its public DNS name. You can also find its private DNS name. And at this point, we still can't access this machine because all the ports are closed. By default, the machine doesn't have any ports open. So we have to set up security groups, which I'm going to show you in just a sec. Another thing to remember is that once you start a machine, you're paying for it by the hour. You pay for the first hour. So if you're just playing around, don't forget to shut it down, or you might be in for a shock at the end of the month when you get your Amazon bill. Basically you just type in stop, instance.stop, and it'll shut it down. And then when it's done, it'll say terminated. Okay, so security groups. So Amazon provides a really flexible way of defining security, sort of the ports that you make available for people to connect into the machine, whether it's port 80 for web access or port 22 for SSH access. And so here's an example of looking at what all the security groups are, and the one you'll usually use is just a default security group that you can assign to all of your machines. Like if you know you want port 22 open on all your machines, you could just add that to your default group. And then other machines, you probably wouldn't want to have port 22 open on all your machines. Maybe you're really security conscious and you want to be able to SSH into one machine and then from that machine be able to connect to your other servers. So once we've created some security groups, this is an example of creating a new Apache group and authorizing port 80. That's what this is from port 80 to port 80. And the second part is basically saying anything can any IP address can access this machine at port 80. Okay, so if we were to assign this Apache security group to that server that we just created, and we installed Apache on that server, then we should be able to access it at this URL. And we should get the classic "it works!" exclamation point from response from Apache. But you may not want to have your web server and your database server and your app server all running on the same machine. You might want to have a 3-tier architecture. And this is an example of how you could authorize internal traffic between your web server and your app server. So we create another security group called App Server, which is our application tier, and we authorize the web group, so that we type in source group equals web, and that allows the web server to talk to the app server. And you'll notice that we've just enabled SSH access on port 22 for the IP address of that machine. So how would we enable SSH access from any machine? What would we have to change here? Does anyone remember from the last slide? Yep, you'd have all zeros right here, and that would allow any machine to be able to access your web server.
They all on like this annoying local machines?
Sorry?
Are they all on like the same subnet so you can restrict it to local machines?
All your machines, if they're in the same availability zone, then they should be all on the same subnet. If you have them spread across different ones, then you might run into some issues with that. So then you can look at the rules and see that, well, here's an example where we revoke the permission after we've added it. So you can add and remove these things. So in order to SSH in that machine, we would change it here to all zeros. And then the command to connect to that machine would then be SSH. You have to pass in the key pair that you created. And then since we're using Ubuntu's AMIs, they don't let you log in as root. You have to log in as the Ubuntu user. And then from there, you can obviously sudo. Okay. So if you guys went to David's talk or Simon Willison's talk from Lanyard, you probably heard about how awesome Fabric is. And so I want to just give a brief overview of what you can do with Fabric. So what is Fabric? It's a Python library and command line tool for streamlining the use of SSH for application deployment or systems administration tasks. And Jeff Forcier is the maintainer, who I met at PyCon, really nice guy. And there's a lot of other people that are contributing to Fabric. There's a fabric.contrib whole ecosystem of people that are building stuff for Fabric that extend it. And it provides a basic suite of operations for local and remote shell commands, uploading, downloading files, prompting user for input, and a whole bunch of other stuff. So let's just look at a really simple example. If you've ever looked at the Fabric tutorial, you'll probably recognize some of this. This is not a very good example because I wouldn't really recommend using Fabric to do your Git commits. But just for purposes of this example, let's say that you wanted to do that. So this is the fabfile.py. It's just when you start out, you can just use a single file. And we're going to import the local module, and that allows us to run local commands, not commands on the remote server, but just on our machine. So in this case, we're just running the tests of our Django app. And if everything looks okay, we add those changes and we commit them. So what does that look like when we run it? Just do fab space prepare deploy, and it runs our tests, and if they pass, then it does the commit. And because this is just Python, you can make it more granular. You can break these things up. So our prepare deploy method is basically just calling the test method in the commit. And what this means is that if there's a test that fails, then it will just abort the prepare prepare deploy command, and it won't try to do a commit because our tests aren't passing. It'll never run the commit task. So Fabric also lets you do some pretty nice failure handling. So you can set an environment variable to warn only, which lets you turn aborts into warnings and allows more flexible error handling. So in this example, we're setting warning equals true, and that means that when the tests fail, you can prompt the user, and you can say, your test failed, are you sure you want to commit? And if they say no, then it just aborts. If they say yes, then it goes ahead with it. If you don't do this, then it's always going to abort. So that's local. If you want to do remote commands, then you import the run command, which I didn't show on this slide, but you'd import run, and then you would pass in the host name. And in this case, we're doing a get pull, and then we run, in this case, we're touching app.wsg, which would restart Apache with the directories serve Django my project. So it's really as simple as that. I mean, it does all the hard work for you. You just put run and then whatever command you want to have run on the server, and it magically executes those commands. So if I run this command, it says no host found. Please specify a host string. So it'll prompt you if you don't specify a server. In this case, its server name is my server, and then it executes the command. So here we're also doing a checkout on the server, so you can also check to see. In this case, we also want to check to see have we done a checkout at all, and if we haven't, then on the first deploy, this will do a checkout of our code. If it detects that there's already a directory there, then it'll not do that step. So one thing if you're doing a git clone is that probably the first time it doesn't know who you are. It needs a username and a password. So Fabric will allow you to have an interactive session. So in this case, it's trying to do a clone, and then it doesn't have the password, so it asks you for the password. So this is all happening without ever SSHing into the machine. You're just channeling everything through Fabric. Now, it's kind of a pain to have to type in my server every time I run this command, right? If the server's not changing, I want to just set that. So Fabric provides a environment global dictionary object. In this case, we have a hosts, and we can set that to our server, and then every time we run this, it'll just use that setting. So that's a basic overview of Fabric. Any questions on that before I move on? Okay. Oh, question in the back?
Also handle things like if you need a TTY, so the program checks if you have a TTY, so you can, for example, input passwords into if you run, for example, password, change the password. Does it handle that like expect does, or does it just move things through a pipe and hope the app runs anyway for this interactive stuff?
So I think your question is, if you run it interactively, are you able to capture the input from the user? Is that?
No. There are some programs that check explicitly if they have a TTY connection and work differently if run in a pipe. So you need to simulate TTY. Does Fabric do this?
I haven't had that kind of situation. Does anyone else here know the answer to that? Patrick?
There's a flag use TTY.
Okay.
There's a flag use TTY? Okay. So yeah, I learned something today. Okay, any other questions? All right. So I'd like to talk about how we're using this at Django Zoom, and just briefly, what is Django Zoom? So it's if you went to Wesley Chun's talk about Google App Engine, I tried Google App Engine in 2008, not long after it was announced, and I really liked the ease of deployment. I love the scalability. But at the time, and I think even to this day, there's still a lot of constraints. There's no LXML, there's no PIL, there's no Postgres or MySQL. You can only have 3,000 files. There's a lot of limitations and constraints. As great as Google App Engine is, and I really wanted to be able to run native Django apps, but with the same benefits of Google App Engine, where you can just push one button and your code is magically deployed and everything's taken care of for you. So Django Zoom is a platform as a service, and we're really trying to make it easy for developers to not have to think about the systems administration stuff. You don't really have to log into the machine. You just give us your code and we take care of it. And the other goal is to provide real scalable and reliable hosting. So I'm just going to go through a few screenshots just so you can kind of get a flavor for how it works. So I'm logged in to the Django Zoom dashboard. I just click on the Add New Project, and I paste in the GitHub URL. Click Next, and it checks out the code, and it starts inspecting the settings file and looking for things about my project. And it also will detect if I have a requirements file in my repo, and it will load that and install all my dependencies. If I just check these over, I can make changes, and if everything looks okay, I say next. And then if everything was okay, I get a job succeeded in less than a minute with a URL where I can go look at my running Django app. If something goes wrong, it will tell me that it failed, and then I can scroll through the log output and see where the failure. Maybe there's an import error, or I forgot to add something to my requirements.txt file. And then I can just fix that, check it back into Git, and then just click the button to build and deploy a new version of the Django app. So it's really designed to be easy to use, really user-friendly, and doesn't require you to install any special plugins on your machine or change your code base at all. So you don't have to create any config files. It basically just intelligently figures out how your app is structured and deploys it for you. So we've taken what is a pretty complex process and simplified it, and that really means that we're, in order to provide the service in a real reliable, stable way, while still being able to respond quick to requests, we need to make the deployment repeatable. Why is it important to create repeatable deployments? Anyone? Scalability, okay. Your machines can disappear, yep. Yep. In the back. Yep.
You have documentation.
Documentation. Yeah, I think you guys hit on pretty much all of my points. So humans make errors, right? So having repeatable deployment, less chance for human error. You can do faster releases and bug fixes when it's repeatable. It's easier to set up testing and staging environments. If you want to do load testing or you want to run a bunch of tests, if there is some sort of failure, you can easily set up a failover cluster very quickly. And like Patrick just said, your documentation is executable. You're basically documenting all the steps that are needed to reproduce your environment, which makes it really easy for a new developer to get up to speed because they can just look at your deployment scripts and get an environment set up quickly. So here's a diagram. I don't know how readable this is back there, but this is kind of an overview of our three-tier, pretty typical three-tier architecture. We have a front-end proxy machine, an app server, and a back-end database server. And then we have a monitoring machine that's watching over all these servers and alerting us if something goes wrong. Then we have a build server that runs all the builds and deploys the code to the various machines. And our fab file in a very simple form looks something like this. We have we call it whip up full system, which creates a fully functioning Django Zoom network from nothing. So we can run this one command, and it creates all of the machines for us in a matter of minutes. So I'm not going to go through all of these Fabric commands, but I'm just going to show the whip up DB node to give you a sense for how this works. So that calls the whip up DB node, and which looks something like this. I apologize for the kind of poor color contrast. I was using Gist to do all my code examples, and then the network went offline, so I had to resort to other methods. So the first thing that the DB node does is it calls a create node. And what the create node does is it creates the node, obviously, and these machines, by default, they don't have very much identifying them from the other machines that get created. So Amazon has eventually provided this way that you can tag a node and give you some, when you look in your dashboard or when you query the machine, it will tell you, what the machine is. You have to set up the public key and assign security groups and assign elastic IPs. So that's all the steps that have to happen in order to create this new node. And Boto makes this really, really easy. So it looks something like this. This is the create node method, and establishes a connection. It finds out what instance type it needs. It gets the user data from a method that I'm going to show you in just a sec. It figures out what security groups it needs, and then it launches the machine passing in all of those. So the user data is a special convention that Amazon has that basically lets you pass stuff into the machine when it first starts up. And we're using a special hook that Ubuntu provides called cloud init. So if we look at the cloud init method, we get the key from our deploy settings file, which is just the name of the key, and then we read it. And then we create this cloud config file, which has the SSH authorized key in it. And this is necessary in order for Fabric to talk to the machine. It has to do it over public key, as I mentioned before. So this user data feature of EC2, along with the cloud init system, which is part of Ubuntu, makes it really easy for us to do this. You can just pass in the key the first time you create the machine, but we found this is a slightly nicer way of doing it. The next thing we need to do is create the security group. So given a certain role, it goes out and creates, if it's a database server, we don't need port 80 open. If it's a web server, we do need port 80 open. So this figures out what ports need to be open depending on the role of the machine. So this is what the get security groups looks like. In this case, if it was a web server, we would open up port 80 and SSH. Next thing we have to do is assign the elastic IPs. And these are hard-coded IP addresses that have been assigned to us from Amazon. So the machines are basically getting this out of a settings file. That's what the IP role map basically maps. Each machine that we have has a static IP, at least the ones that need to have static IPs. And I mentioned before that you can tag a node, so this allows us to give each machine a unique name so we can keep them all straight. So with this single command, create node db, we just launched a new database server with everything set up with proper IP and proper security group and a key pair so we can log into the machine. And then Fabric handles all the setup. So we just use Boto to get the machine configured in the right way, and then Fabric is what we use to log into the machine and configure it. So going back to our whip up DB node method, we're now here. And what does this look like? we do a package upgrade on the machine, and then this is where we install all the Ubuntu packages that we need based on the role of the machine. So we pass in the role is database, and let's look at what that looks like. So this is our package role map. So there's a default mapping that is a list of all the packages that will get installed on every machine. So like Git and Mercurial and Supervisor get installed on everything. Then the database server has its special packages, app server, proxy server, alert monitoring server. And then we return the package role map. And this is what the apt install method looks like. Basically, it just gets that list of packages and calls sudo. And we could just use run since we're doing this as root. And you have to remember to do Debian front end equals non-interactive, or else some things like postfix will prompt you for all kinds of stuff. So you have to make sure that there's no interactivity when you install packages in this way. Okay, so that was installing the packages, and then the next thing is to actually set up Postgres. So we call another create DB method. That's this line, and we create a super user, and then we created a little configuration or a little shortcut to installing configuration files where we just reference the full path, and then we have a directory in our Fabric folder that uses the same path structure. So that way we can kind of keep all these config files straight. And then lastly, we restart Postgres after we've copied these in. So let's look at the create DB. This isn't the whole thing, but I just took out the sudo. In this case, I wanted to highlight that we're using sudo here because we don't want to do this as the root user. We want to do this as the user Postgres so that the database is owned, or these commands are being executed as user Postgres, not as user root. The owner can be someone else. We can set that to whatever we want. Yeah. Okay, so once again, a single command to create and set up an entire cluster. We type fab, whip up full system, and we basically have the entire Django Zoom network is up and running. And I just showed it for the database server, but all those other servers are done pretty much the same way. We have different Fabric commands for each machine. So if one machine goes out, we can just say Fabric, whip up DB node or whip up this, and it starts up those machines. Okay, so I just want to check the time. We've got another. It's 3:30, right? Another half hour. Okay. So let me just show you guys a little bit sort of how we do our day-to-day deployments. I don't know why the projector keeps going out. So when we first started out, we just had like one, update the web server, update this server, update that server, and that got to be kind of tedious because, sometimes we didn't need to update everything. We just needed to update like one CSS file or something like that. So we created this little quick update method, which prompts us and says, do you want to update all the Celery-based code, or do you just want to update the user control code, which is like sort of the forward-facing website? And then we didn't want to have to like have pip reinstall the dependencies every time, but sometimes you do upgrade to something new. So we also prompt to say, do you want to upgrade the dependencies? And then lastly, do you want to look for a new version of Django? So this allows us to do very quick updates and only do the steps that we need. So sorry, the yellow is, you guys all know Python, so you can like fill in the blanks. So it's like Hangman. You can figure out what the yellow parts are. So this is just basically checking the web node and updating the web server with any new code. And if we've confirmed that we want to do a pip reinstall, then it it will reinstall the dependencies. Otherwise, it skips that. And this is an example of how we use tags. So we query the machine, the node object, and we look at the tag, and we check the tag. We call it the rabbit roll. And if the rabbit roll is web, then we know, okay, that's the web server. So that's the right machine to update. This is the method, the actual web update deployment method that does a git checkout master and git pull, and does the reinstall, the pip reinstall. And then it will also sync the Django database, and if there's any migrations that we need to run, it also does that. Again, rollback support is really important. That's something that everyone should have. I'm not going to show an example of that, but so that's most of what I wanted to talk about. I want to have plenty of time for questions, but just in closing, I want to talk about a few other tools that might be alternatives or complementary tools to Fabric. So there's these configuration tools, Chef and Puppet. So where Fabric is more procedural, Puppet and Chef are declarative. And where Fabric is more of a push mechanism, Puppet and Chef are pull. So they're actually pulling configuration information from like a centralized server to figure out what needs to be installed on this machine. So almost everything that I showed doing with Fabric could be done with Chef and Puppet. But the nice thing about Fabric is that it's all Python. And if you're not managing like dozens or hundreds of machines, it's works pretty well. And for doing like quick updates, if the push method is a lot better than having to wait for Puppet or Chef to get around to updating the code on your servers. Another tool that has been getting a lot of buzz lately is something called Vagrant, which lets you create VirtualBox machines for doing like local testing and staging, creating like an entire staging environment just running on your local machine. It's just like one command to launch a new instance. Another tool is DevStructure, which sort of like reverse engineers your machine. If you log into it and you install a bunch of packages and move configuration files around, it lets you create a blueprint of everything you did on that machine, and then create a Chef or Puppet recipe or even a bash script. So you could reconstruct what you did on that machine. So I was talking pretty much just about Amazon, but if you don't want to use Amazon, there's other providers out there like Rackspace, and Jacob Kaplan-Moss created something called Python Cloud Servers, which is a client for Rackspace. And there's also the libcloud project. I think there was a talk yesterday about this, which is now an official Apache project. So that gives you sort of like an abstract library for accessing a whole bunch of different cloud providers like Linode or GoGrid. So if you want to have the most flexibility and not be tied to any one particular provider, probably best to like build on top of libcloud, because then you can easily switch to different providers. You might miss some of the more Amazon-specific functionality that's not provided with libcloud. And if you don't want to use public clouds at all, and you want to build your own using something like Eucalyptus or OpenStack, I think both of those support the Amazon API. So you could use Boto with your own machines and create virtual machines like in your own data center or your own. You got a bunch of boxes sitting in your house and you just want to play with this stuff. You can do that. So that's it. I want to say thanks to PyItalia for putting on an awesome EuroPython this year. This is my third, and the food is definitely the best. This one, you guys know how to have great food. And then Mitch Garnett for making the Boto and maintaining this really great library, and Jeff Forcier for the great Fabric tool. And with that, I want to open it up for questions.
The main thing I see that is a bit surprising to me, but I mean, maybe it's a trade-off that you accept, but fabric is not idempotent, right? Idempotent? I'm not sure about the pronunciation.
Fabric is not what?
Idempotent.
Oh.
It's like you have dependency system and repeatable steps, and every part knows if it needs to be done again or not. So you can just change some parts, and then you run the configuration again on the machine or whatever, and it will only do the parts that it needs to do again.
Yep.
And I don't know, I've looked on the internet, and there is a fabric idempotent project. Maybe if you had a look, I don't know.
I haven't looked at that yet. No.
How do you do backups and recovery?
How do we do backups and recovery?
Yeah. If it goes down, how do you get the same data and the same project running?
So for our own stuff, we have backups of the database that are run nightly, and then we also we use the EBS snapshots to take a snapshot of the entire EBS volume. So in the event of a failure, we have a snapshot that we can restore the EBS volume.
And is it automatic, or do you have to go to the Amazon dashboard and?
We have scripts that can do the recovery for us, but it doesn't like auto detect that there's been a failure and then restore from backups. That's still a manual process.
Okay. Thanks.
Okay.
Okay.
Thank you.
Yep.